Hello, everyone. Today's seminar lesson, I'm going to walk you through some of the example of how to solve trigonometric substitutions. Okay, so before we go into the examples, I want to show you some of the form that desire to guide you to use it appropriately for each of the trig substitution. Okay, so for example, I have integral of dx over x to the 4 times the square root of x squared minus 3. So if you look at the bottom, square root of x squared minus 3, you see that we're going to use this telling you that we're going to use x equal a secant theta, right? So I'm going to let, now here I'm going to, so here is a is 3. A squared is 3. So a squared is 3. So this implies a is the square root of 3. Well, plus minus the square root of 3, but we're just gonna take the positive case here. Okay. All right. So a is the square root of 3. So now that I'm gonna let my x equal a secant theta. A is the square root of 3 secant theta. Dx is, if you take the derivative with respect to theta, dx is what? Dx is square root of 3. Derivative of secant theta is secant theta tangent theta, d theta. Okay, d theta. All right, now I'm going to plug it back into the original problem. So this one becomes integral. We know that dx is this here, right? That's my dx. So dx is the square root of 3 secant theta tangent theta d theta over x to the 4. So x to the 4 here is all you have to do is you take that to the power of 4. So root 3 to the power of 4 is 9, right? It's 9. And then we have secant to the 4 theta. And then square root of x squared, all you have to do is you square the x, right? X squared, like that. X squared is not, not 9, is 3 secant squared. Let me rewrite the secant a little bit neater. Secant squared theta minus 3. Okay, now let's clean it up a little bit. So I have integral. The first, I'm just going to rewrite the top. So square root of secant, square root of 3 secant theta tangent theta d theta over, I have 9 secant to the 4 theta. And let's see, this part right here, I can factor out the 3, right? I can factor out the 3. So this is equal to square root of 3 secant squared theta minus 1. And secant squared theta minus 1, that's tangent squared theta, right? Tangent squared theta, that's one of the trig identity, right? So we have 3 times tangent squared theta. If you take the square root of that, I have square root of 3 tangent theta. Okay, so that become 3, maybe I'll use green here, square root of 3 tangent theta. Okay, let's do some simplification. Right? So I can simplify this with this, this with this, right? And then the secant, one of the secant, right? One of the secant. Maybe I'll use purple. This one with one of the secant. Right? Now this is secant third, right? Okay, so we have equal. So now it's equal integral. The top is just 1, right? Top is just 1, and we have d theta here. The bottom is 9 secant third theta, secant third theta. Okay. Or better yet, if I do one more time, I'm gonna bring the 1/9 to the front, and 1 over secant cube theta is cosine cube theta, d theta. Remember, secant theta and cosine theta, they are reciprocal function of one another, right? Okay, for the cosine cube theta, I'm gonna split it into cosine theta and cosine square theta. So again, this I'm gonna do right here. So this part right here, oops, too dark. This part right here is, I'm gonna rewrite it as cosine theta times cosine square theta. But we know that cosine square theta is equal to 1 minus sine square theta, right? So in fact, this is what I'm gonna do. I'm gonna rewrite this. So in fact, this is equal to, maybe I'll go down here. This is equal to 1/9 integral of cosine theta times 1 minus sine square theta d theta. Okay, and now I'm gonna use substitution. Okay, so now I'm gonna let u equal sine theta. So this implies du equal cosine theta d theta. Okay, cosine theta d theta. So now I'm gonna plug it in and see what we have. So we have 1/9 integral cosine theta d theta, that's du. And then inside the parenthesis is 1 minus u squared. And now we can integrate. Okay. So this is equal to 1/9 u minus u cubed over over 3 plus c, right? Plus c. Okay, remember, we trying to solve things in terms of x, right? In terms of x. So you have to keep track of what we did. We're gonna keep track of what we did. So in the beginning we had x. So let me keep track of what we did. In the beginning we had x, and now we turn it into a theta, right? We turn things into theta, and then we turn things into u, right? So in order to get back to x, we have to go through the step again. So you have to, from u, you have to go back to theta, and then from theta to go to x. Okay, you're gonna keep track of the variables here, right? Okay, now I had to bring things back into theta now, and then from theta to x, right? So this is 1/9. U is, I let u equal sine theta. So sine theta, instead of u, it's going to be sine theta minus u cubed will be sine cubed theta over 3 plus c. All right, so from u, I bring it back to theta. And now from theta, I have to bring it back to x term, right? In order to do that, we have to draw a right triangle, right? So a right triangle. Maybe I'll right triangle. So let me I'll use yellow, that's fine. I'll use yellow. So I'm assuming it's going to first quadrant. So look like this, my right triangle, right? So see what we have in the beginning. In the beginning, we let x equal square root of secant theta. I'm talking about this part right here. Okay. Right. So let me erase all that little red part. So I'm going to rewrite this. In the beginning, we let x equal square root of 3 secant theta. In the beginning, we let x equal square root of 3 secant theta. Or secant theta equal x over square root of 3. Or better yet, cosine theta equal root 3 over x. Right. So here's my theta. Cosine is adjacent over hypotenuse. So adjacent is root 3, hypotenuse x. So this part right here will be x squared minus 3, right? Using the Pythagorean theorem, right? C squared equal a squared plus b squared, right? Okay, now sine theta. What's sine theta? So from there, I can solve for sine theta. Sine theta is equal to, sine theta is opposite over hypotenuse, right? Opposite is square root of x squared minus 3 over hypotenuse is x. And now I'm going to plug it back. I'm going to go from theta into x now, right? I'm going to go from theta to x now. So this equal 1/9 sine theta. Instead of sine theta, it's going to be square root of x squared minus 3 over x minus sine cube theta. So it's going to be square root of x squared minus 3 cube over cube x cube, right? Over 3 cube would be 20 x cube. So it's x cube divided by 3 x cube divided by 3 or times the reciprocal times 1/3. So it'll be 3 here. Yeah. Okay. So that will be our final answer. Okay. Okay. If you don't understand any part, please go back to my video and watch that part. Okay. All right. Example. Problem B. I have integral from 0 to pi half cosine t over square root of 1 plus sine square t. So this one, it doesn't look like any of the strict sub. So what I'm going to do is I'm going to let u equal psi t, right? So I'm going to let u equal psi t. I'm going to let u equal psi t. So du is cosine t. Right now I'm going to rewrite this. So this become is, I'm not gonna write the limit now, okay? I'm just gonna ignore the limit for now. We'll plug it back at the end. So cosine t is cosine t dt. Oops, sorry, dt. Cosine t dt, that's du, right? And it will be 1 over square root of 1 plus u squared. 1 over square root of 1 plus u squared. So which one we're gonna use? Plus, so this one right here, right? Square root of a squared plus x squared. Here a squared is 1, so square root of 1 is 1, so a is 1. Right, so here let's see what we're gonna let. We're gonna let x, or better yet, or u in this term, u equal a tangent theta. U equal, gonna let u equal a is 1, so I'm just gonna write a tangent theta. So just 1 times tangent theta, or tangent theta. So remove that 1 there. du is secant squared theta d theta. Now again, you're gonna keep track of your variables. Okay, so in the beginning we have t, right? So let me keep track of my variables so I don't get confused at the end. So in the beginning I got t, and then what I did is I let u equal psi t, so I turned it into u. And then what else I did? And then I turn it into theta. I let u equal tangent theta, right? So I turn it into theta. So what your job is, at the end, you have to work it backward. You have to work it backward, back to t. Okay, so we're gonna have some bookkeeping, right? Okay, so u equal tangent theta, du is secant square theta, d theta. Right? And then we plug it into this blue thing here, now become green. This one equal what? Integral of du is secant square theta d theta. That's the top. The bottom is square root of 1 plus u squared. So 1 plus tangent square theta. Okay. Now 1 plus tangent square theta. That's secant square theta. Right. This part right here. This part right here. This is equal to square root of secant square theta, or equal to secant theta. Okay, so and then what, secant square theta divided by secant this, so this is secant theta. Then further simplifying further, we have equal to secant theta d theta. And the antiderivative of secant theta is ln of secant theta plus tangent theta, and then plus c, but we're just gonna ignore that part for now, okay? Because this is definite integral, all right? Okay, we still in term of theta, right? Now what the bookkeeping, we're gonna go from theta to u, from theta to u, right? So from theta to u, how do I do that? We need to draw a right triangle. A right triangle again is going to be in the first quadrant, just like we assume, right there. Okay, so here is my theta. Here is theta. It's theta. Okay. So theta. So remember we let u equal tangent theta. U equal tangent theta. U is opposite over adjacent, y over x. So what y, so that mean y here will be u, right? Y here will be u, and the adjacent will be 1, u over 1, right? U or u over 1. Okay. Or that better yet, I can figure it out. This part right here going to be u squared plus 1. U squared plus 1. Square root of u squared plus 1, right? Okay, so now we can solve for some stuff. Now we can solve for cosine theta. Why? Because I need secant, right? Cosine is adjacent over hypotenuse. Adjacent is 1 over hypotenuse is square root of u squared. That's u squared plus 1. And from cosine theta, I have secant theta, which is just flip it, right? Secant. Why do we have secant theta is u squared plus 1 over 1. We're not going to write that, right? So here from the green function here, expression here, I'm going to rewrite this as what? I'm going to rewrite this equal to ln of absolute value secant theta is square root of u squared plus 1 plus tangent theta is u, right? Is u. It's u. Okay. All right. Now, the last step is we're going to turn u to t. Turn u to t. Remember, we let u equal psi t, right? U equals psi t. So whenever I see u, it's going to be psi t. Psi t. So this is equal to, go back to the blue one. Instead of u, it's going to be psi t. So in this case, psi squared t plus 1 plus psi t. And we're going to evaluate from what was the limit, 0 to 2 pi, pi half, 0 to pi half, 0 to pi half. Right. Now because we turn everything back into t term, we can use its limits, right? The limits of t is from 0 to 2 pi half. Okay, right, plug it in. Upper limit first. Psi t squared, so it'll be psi square pi half plus 1, oops, don't forget the square root, plus size of pi half minus the lower limit, which is square root of psi square 0 plus 1 plus size of 0. And now we're gonna do some simplification. Okay, let's see. Psi square of pi half is the same thing as, so this one right here, it's the same thing as size of pi half, all of that square, right? And we know size of pi half is 1, and 1 square is 1, right? And 1 plus 1 is 2, so that'll be square root of 2 there. So this will be, this part right here will be square root of 2, right? So equal ln of square root of 2. I'm gonna do it slowly. This one right here, size of pi, pi half, we know that's 1, right? It's 1. So that's equal 1. So plus 1 minus, what happened here? Size of 0, size of square 0 is 0. Plus 1, so it's just the 1, so it will be square root of 1. Well, square root of 1 is 1, right? So 1. Let me see. So 1 here and plus 0, right? Plus 0. Okay, so what we have, did I do something wrong? I did something wrong, didn't I? Oh, yes, I did something wrong. I forgot the ln here, right here. I forgot. Maybe I'll do in purple, so in red. So you know where was my mistake. I forgot the ln there. To be ln here. Yeah, lower limit. Okay, lower limit. ln. Like that. Okay. Like that. Oops, I don't have enough space. But you know the deal. Just gonna do the absolute value instead. I don't need the parenthesis. I don't need the parenthesis. There. Okay, better. Yeah, I don't need parenthesis. I'm just gonna get rid of parenthesis. Okay. All right. Okay. Now. All right. Okay. So so the first part is I have ln of square root of 2 plus 1. I know this is going to be positive, so I'm going to turn the absolute value into parentheses, right? Ln of 1 is 0, so nothing there. This one is 0. Okay, so the final answer is ln of square root of 2 plus 1. Okay. All right, thank you for watching.